Hello, so today we're going to look at the impact of scale factor on area of objects. We know that when you have a scale factor, you are going to multiply all of the side lengths by that scale factor, but we want to see now what does that do to the amount of space that's inside of a shape. So we're going to start with this guy here. We have one rhombus, and if you have a scale factor of 1, that means you have exactly the same shape that you had before. So 1 by 1 by 1 by 1. How many shapes does it take to make this? It takes 1 block here. So I can mark in for myself when I have a scale factor of 1, it's going to take me 1 block. When I have a scale factor of 2, that means I need to take and make every side length twice as long. So where it was 1 shape long before, now it's 2 blocks long. It needs to be 2 blocks tall though too, because it was 1 block tall before. So now I have a shape that is identical to the previous shape, just 2 times as long on every side. When I do that, I have 4 blocks that I need. So at a scale factor of 2, I'm going to need 4 blocks. Scale factor of 3, well, now every side needs to be 3 blocks long because every side was originally 1 block long. So I'm 3 long. Well, now I'm 3 by 2. So it looks kind of like my trapezoid, or excuse me, my rhombus from before, but it's only 2 long on the tall side where it's 3 long below. So I need to keep going so that I'm 3 long on every side. Now that looks good. That looks identical to the one before, but I just took every side length and multiplied by 3. That needs 9 blocks. 1, 4, 9. Let's see what happens if I need 4. It needs to be 4 tall as well. So it's now 4 by 4, and it takes 16 blocks to make that scale factor. So then as I look at this, students started to notice some things. They said when there was 1, 2 gave me 4, 3 gave me 9, 4 gave me 16. They were noticing that was like doing 4 times itself was 16, 3 times itself was 9, 2 times itself was 4, 1 times itself was 1. So I would expect 5 times itself, I would expect this to be 25 blocks. Let's confirm. It's 5 long on every side. Now I need to go 5 up. And it does take 25 blocks. Ooh, nice. Okay, so we're going to hold on to that for now, and we're going to look at triangles. So when I have one triangle exactly with a scale factor of 1, so it's the original triangle, it's going to take 1 block. 2, I need to now scale factor it so it's twice as long. Well, it's twice as long on the bottom, but I also needed to make it twice as long on every side. Now it's 2 by 2 by 2, so that's good. Ooh, that takes 4 blocks. Starting to notice maybe some similarities. Now I need it to be 3 by 3 by 3. It's 3 by 3 by 3. That takes 9 blocks. Well, now, looking across at the rhombuses, my expectation, my conjecture would be 16 and 25 for a scale factor of 4 and a scale factor of 5. Let's confirm that. At a scale factor of 4, where every side is 4 long, we have 16. At a scale factor of 5, where every side is 5 long, ooh, it takes 25. Intriguing. Let's end with our trapezoid. So the trapezoid is a little bit trickier because if I want to try to make something that's going to continue to be a trapezoid, I might end up with some half lengths. So I need to make the bottom 2 long, and the top, well, it was the bottom was 2 long, so I need to make it 4 long for a scale factor of 2. The top was 1 long, so I need to make it a scale factor of 2 for the 2 long. Ooh, so I had to move them around a little bit more. But along the bottom, it was 2, and now it is 4. And the top was 1, and it now is 2. So that looks pretty good. And on the sides as well, it was 1, and now it's 2 of those, because it's the same as up top, and was 1, and now it's 2, same as up top. So when we had a scale factor of 1, it just took the one trapezoid. Scale factor of 2 takes 4. So now my conjecture would be that this would take 9, looking at the patterns, 16 and 25, but let's be sure because it is a different shape. So I would need now, instead of being 2 long, I need it to be 6 long. So it's 6 long along the bottom, 3 long along the top, 3 long on each side, and that takes 9 blocks. And to be 8, we're 1, 2, 3, 4, 5, 6, 7, 8 by 4 by 4 by 4, and that takes 16. So the same pattern holds for all of these. Let's see if we can notice any rules. We said 1 times 1 gives us 1, 2 times 2 gives us 4, 3 times 3, 4 times 4, 5 times 5, so I would expect 10 times 10, which would mean I would need 100 blocks here. So I can use what I've noticed about a pattern to do a much larger problem that would be really onerous or annoying to have to do by hand. So now if this is not 5 but S, any blocks, any scale factor S, I would just multiply by itself. And SS is the same as taking S and squaring it. So we could say that every scale factor could be squared to get the area. Which means that then if I have a half length, I don't want to cut my blocks in half, but I could do 1/2 times 1/2, which means I would have 1/4 the number of blocks. Just a little bit odd, because now my scale factor, my area is actually going down. It's smaller than it would have been originally, rather than larger than it would have been originally. So that's interesting there. So we notice this happening when we have just the one block. Let's see what happens if we have more complex blocks. So looking at these. We want to try to make this into something that has every side length is twice as long as it was before. So let's turn this. It was 4. So it was 2, now it's 4. It was 1, so I need it to be 2 long. So it's 2 long here. It needs to be 2 long along the bottom as well. And that means I should probably fill in some pieces. And we need, where this was 1 before, we need it to be 2 long. So let's see about that. So I now have a shape that is twice as long on every side. Where it was 1, it is now 2 long. Where it was 2 long, it is now 4 long. It originally took 3. At a scale factor of 2, it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for this shape, when my scale at a scale factor of 1, it's 3. At a scale factor of 2, it is now 12. If we go a little bit further and we look at it with a scale factor of 3 and we built it out, we would find that it needs 27 blocks. And if we have a scale factor of 4, we would find that it would need 48 blocks. So we are not following exactly the same pattern. It's not every number the same as it was before, but people noticed that as you went from 3 to 12, that was times 4. And that was the number we saw here. As you went from 3 to 27, that was times 9, which is what we saw for the scale factor. with a scale factor of 3. And going from 3 to 48, that's times 16, which is what we saw happening when there was a scale factor of 4. So it seems like this 4, 9, 16 pattern is still holding, but now because we had a different starting number, not 1, that's what's affecting what's going on here. So as you increase your scale factor, the area, or the number of blocks needed, area, is going to increase by whatever your scale factor is squared, or s times itself. And that means that scale factor has a different effect on area than it does on length.